So now we have two different ways of measuring angles. We have degrees and we have radians. And the question is, how are these two things related to each other? This relationship right here, 360 degrees equals 2 pi radians, is the fundamental relationship that we need to keep in mind. We talked last time about the 360 degrees in a circle, but what about 2 pi radians? Where does that come from? Well, if we think about a circle, you might be familiar with the formula circumference is equal to 2 pi r. Circumference is the distance going around the circle, and r is going to be the radius of that circle. Now, if we think back to last time, theta equals the distance traveled divided by the radius of the circle. We can use this picture. If we go one full trip around the circle, our theta is going to be s over r. Well, that s, that distance s, is just the circumference. 2 pi r over r equals 2 pi. And so one full trip around the circle, one full rotation, is 2 pi radians. So now that we have this relationship, the question is, how does this help us convert between the two? Well, the most common way to think about this is the application of what's known as a conversion factor. We can take this thing and turn it into two fractions, 360 degrees over 2 pi radians. And this will equal 1, and that's by dividing both sides by 2 pi radians. Or if we divide both sides by 360 degrees, we get this, 2 pi radians over 360 degrees. And so to convert from degrees to radians or radians to degrees, you have to multiply by the correct conversion factor to make sure that your units cancel out. One side note about these units. Radians, technically speaking, are what are known as a pure unit. They're just a number, and that's because we have distance over distance here. But it is helpful to write the word radians when you're talking about angles so that you don't get confused just seeing 2 pi floating around on its own. Reminding yourself that you're talking about an angle here. So we will tend to write the word radians here, even though it's strictly speaking not necessary. For our first example, we're going to convert 330 degrees to radians. Now, the way we use our conversion factors is that we need to multiply our value by the appropriate fraction to make the units cancel out. So in this case, these 330 degrees, the degrees are on top, and so we need to have degrees on bottom. So 360 degrees on the bottom. 360 degrees is the same as 2 pi radians, so we put that on top. From here, it's just a matter of arithmetic. Now, you can multiply the tops first and then try to reduce, but I'm going to reduce first because it makes our life a little bit simpler. So we think about 330 divided by 360. Well, we can divide out the 10, so we have 33 over 36 divided by 3, so that's 11 over 12. So 11 over 12 times 2 pi radians. The 2 and the 12 reduce even further, so we have 11 pi over 6 radians. Now, I use the conversion unit 2 pi radians over 360 degrees because that's the fundamental relationship. Some students prefer to just use pi over 180 degrees, so pi radians over 180 degrees, because this has already been reduced. That's perfectly acceptable. Either one is fine. I just use this to emphasize the point that the fundamental relationship is 360 degrees is 2 pi radians. For this example, we're going to convert radians to degrees. Specifically, we're going to convert pi over 3 radians to degrees. Now, the same idea applies. We're going to multiply by a fraction to make the radians cancel out. So we have radians on top, so we want 2 pi radians in the denominator, so that's the same as 360 degrees on top. So now the radians cancel out. Now, as we said before, technically these radians are pure units, and so they actually don't appear, but it really is helpful to write that down. So radians cancel out, the pi's will cancel out, and if we look at the denominator, we have a 3 and a 2. 3 times 2 is 6, so 360 degrees divided by 6 is going to be 60 degrees. Now, one mistake that students tend to make is that as soon as they see pi's, they assume they are in radians. This is something that is generally true in applications, but you need to be careful of it. It is possible for us to have something like pi degrees. And it's also for us to have something like 3 radians, where there is no pi. And so don't fall into the trap of assuming that, oh, if it's pi, it's in radians, and if it's not pi, then it's not in radians. That's not quite how this works. You should think of this specifically. Pi is a number, and if we're talking about a measurement, we're either going to say radians or we're going to say degrees. and you have to be able to follow that language and not just focus on the pi. When we're talking about angles, there's an important concept we need to think about, which are known as coterminal angles. Now, coterminal, the prefix co, means together. And so you can think of words like cooperate, to operate together, or to work together. So coterminal angles are angles that end together. Now, implicitly, it means that they also start together. So if we have some initial side and some terminal side, coterminal angles are angles that start from the same initial side and end at the same terminal side. So how can we get lots of different coterminal angles? Well, it depends on how we measure. So here's one way of measuring this angle. Alternatively, we could have gone in the negative direction and measured it that way. And if you think about it, we could actually go even further. We can do a full loop around and then end up at this angle. And so these are lots of different ways we can get the same angle, we can measure the same angle, but get different results. And so when we say that we have coterminal angles, we're saying that these angles are related to each other, same initial side, same terminal side, even though we get different measurements. Now, the nice part about these measurements is that they are all related to each other in a very clear mathematical way. If we're talking about degrees, then this angle right here from here to here, and this angle right here from here to there, those are 360 degrees apart. And you can sort of imagine if we try to create this negative angle, if we go up to this positive angle, and then go backwards, go one full loop in the negative direction, that's how we would get this angle. And that one full loop is subtracting 360 degrees. Same thing happens in radians. With radians, you're going to be adding or subtracting multiples, integer multiples of 2 pi. And so two angles are coterminal with each other if their difference is an integer multiple of some complete measurement of a circle. So either 360 degrees or 2 pi radians. Here's an example using coterminal angles. Find an angle coterminal with 19 pi over 4 on the interval from 0 to 2 pi. Now, a couple quick words about this. The book will often do this. It will just say 19 pi over 4 without saying radians. This comes back to the idea that radians are technically not even a unit. It's just because you have a ratio of length over length, so it's just a pure number. But typically, I would try to encourage you to say radians here, even though it doesn't say so. Now, the important thing about that is that it's not radians because of the pi. It's radians because it's not degrees. If you see a degree symbol, then it's definitely in degrees. If you don't see it, then it's definitely in radians. And so that's how you tell the difference between the two measures. The interval from 0 to 2 pi, well, that's one full rotation. And so we're looking for the angle sort of measured in the positive direction, the smallest positive solution, or smallest positive angle that matches up with this one. Now, there are a couple of different ways of doing this. You can do it geometrically. I'm going to do this algebraically, because later on we're going to see a more geometric approach to this. 19 pi over 4. Now, to find another angle that is coterminal with this, we can either add or subtract 2 pi. Now, in this case, this number is a big number, so we're trying to get ourselves down to this interval from 0 to 2 pi, so we're going to subtract 2 pi. So 2 pi, and this is going to be 19 pi over 4 minus 8 pi over 4. Find a common denominator. That's 11 pi over 4. Now, some students are quick to say, okay, well, therefore, the answer is 11 pi over 4. You have to think about what these numbers actually represent. 11 fourths. What is 11 fourths as a mixed number? 11 fourths is 2 and 3 fourths. And that's still bigger than the 2 pi over here. So 2 and 3 fourths pi is bigger than 2 pi. And so we're not done yet. We have to make sure we actually end up in this interval. So we're going to have to subtract off another 2 pi. 11 pi over 4 minus 8 pi over 4, which is equal to 3 pi over 4. Now, this fraction 3 fourths is less than 2. So 3 pi over 4 is less than 2 pi. And this will be the final answer. This is the angle that is coterminal with 19 pi over 4 on that interval.